All right, in section 1.2, one of the most important concepts that we'll be talking about is echelon form of a matrix or of a system of linear equations. Okay, echelon form. How do we get that? How do we get the echelon form? By reducing rows. So it's row reduction and echelon form. So these are the two things that we'll be talking about. So what is echelon form? Here is the definition. A rectangular matrix is in echelon form, or sometimes called row echelon form, if it has the following three properties. I want you to read that three properties. Properties number one, all non-zero rows are above any rows of all zeros. Look at this. The last term, all the zeros, they must be on the bottom, okay? Non-zero element, this star represent, they could be zero. I mean, you know, this non-zero is represented by this star or this box. Any rows that has all the elements zero must be on the bottom. It cannot be on the top. Keep that in mind. Property number two, each leading entry, which means we call it pivot later on, leftmost non-zero entry of a row is in a column to the right of the leading entry of the row above it. So this is represented in part B. You can see here. And all entries in a column below a leading entry are zero. That means suppose this one is your pivot, okay, leading entry. Below that, everything must be zero. And there is another leading entry, we call it pivot, by the way, later, okay. Below that must be zero, and below that must be zero. These are the pivot, okay. So the matrix that satisfies these three conditions, we call it, the matrix is in echelon form. And there is another word, reduced row echelon form. And in short, we call it rref, reduced row echelon form. Okay, echelon form and reduced row echelon form. What's the difference? Well, in order for the echelon form to be reduced row echelon form, it has to satisfy two more properties. Property number four, the leading entry in each non-zero row must be 1. For example, here in the earlier case, we could have any number. But if you want to change it into rref form, then it must be 1. All of these pivot position must be 1. And notice that anything below 0, look at the property number 5. What we said earlier in echelon form is anything below the leading entry is 0. But in order for this to be rref, below and above must be 0. If this is a leading entry or pivot, below and above must be 0. If this is leading entry, below and above must be 0. Okay, so that's these two extra properties. If the matrix satisfies these two extra properties, we call it a reduced row echelon form. So let's try few example here.
Professor,
yes.
Can you give example of triangular matrix?
Yeah, we're gonna do that later, don't worry.
Okay.
This is one example of triangular matrix. We call it upper triangular. Anything below that diagonal is called, I mean, this one is the diagonal. Below that, all zero, we call it upper triangular. And in the same way, we can define lower triangular. We'll talk about that later, don't worry. Okay, now, so with the help of this example, I'm gonna explain what is this pivot position means, what is that pivot, and what is pivot column and pivot row. So these are the things that we'll be talking about. Now, here is one example. Okay, let us consider a matrix. Now, in this matrix, of course, this is your pivot. This is your first pivot or leading entry. Another word is leading entry. You can say that. But from now onwards, I'm gonna call this pivot, okay? Now, in one column or one row, there could be only one pivot, okay? Now this column, this row, and this column is gone. Now go down, and this is your next pivot, okay? And now this row and this column is gone because there can be no more than one leading entry in each column and row, okay? Only one leader. And now this is gone. So now go down. So since this is zero, it cannot be the leading term. It cannot be pivot. Go down now, next here. So it cannot be pivot. So there are, now if this is not the case, then you go to the next one. 5, this is your pivot. Now in that row and in that column, there can be no other pivot. So now go down, since this is 0, it cannot be the pivot. Therefore, the pivot in this case are, this is your pivot, this is your pivot, and this is your pivot. All right, and so now let me pivot are 1, 2, and -5. Pivot column are, what are the pivot column? Column number 1. The first column is pivot, as you can see, okay? Column 1, column 2, and column 4. They are the pivot column. And what are the pivot row? The rows that has pivot. Pivot rows are row number 1, row number 2, and row number 3. So they are pivot rows. Any questions so far?
No.
Now let's look at another example. Consider the matrix. Identify the pivot column, basic variable, and free variable. Write the reduced system of equation and find the general solution of the system. Okay, let's work on this question. So first of all, notice that in order to figure out what is the pivot, we must change the given matrix into echelon form. Okay, so first we need to change given matrix into echelon form. By using the row operation. And I think we have done this in our previous class. So in order for this, what is the first thing you may want to try is maybe R1 and R2, because this one is 0. We don't want that 0. Okay, I want to do maybe this is, you can switch R1, R2, you can switch R1 and R3, or you can switch R1 and R4, because I see that there is a positive value. So I want to switch R1 and R4. But you are free to switch, change, interchange R1 and R2, R1 and R3, no problem. Let's do this. If I do that, what I'm going to get is 1, 4, 5, -9, -7. And the second row remains the same. We did nothing. And the third row remains the same. We did nothing. If I copy the wrong number, please let me know, okay? And the last one will be 0, -3, -6, 4, and 9. Okay. Now remember here, we are trying to make, this will be our pivot position. That means anything below the pivot must be 0. So we need to make this guy 0, this guy 0, the same way that we did in our last class. So in order for this, maybe what you can do is in R2 plus R1. So that guy will become 0. And in R3, you may want to try this R3 plus 2R1. Then both of these guys will be 0. So let's try this. In R2 plus R1. You can do that in your head, I think. So the first row remains the same. You do nothing there. And in the second row, we're going to add R1 and R2. That gives me 0. That gives me 2. And 5 minus 1 is 4. -9 and plus 3 will be -6. And -7 plus 1 will be -6. Right? And in R3, let's try that. R3 plus 2R1. R3 is -2, -3, 0, 3, -1. And this is your R3. And we're going to do 2R1, which means 2, 8, 10, -18, -14. So if you add them, you're going to get that 0. This will be, how much is that? 8 minus 3 is 5. And this will be 10. This will be -15. And this is -5. All right. So I'm going to get 0, 5, 10, -15, and -5. And the last, we did nothing, just copy as it is. Okay. Now our goal is to, now you see this one is our pivot. So since,
Professor,
yeah,
when we do the 2R1, we are gonna get 2 into 7, 14, but you accidentally wrote 4.
yes, I was checking how many of you are paying attention. Thank you so much. This is -14 and -1 will be -15. Thank you. Okay, good job there. All right, so if you want to take any common from R1, R2, R3, if anything can be taken common or divided by certain number to make life easy, go for it. You don't have to do it, but that will make life easy, I think. So I see that what I can do is in R2, I can divide by 2, and R3 I can divide by 5 in order to make life easy. Again, it's not a requirement, okay? Keep that in mind. That makes life easy because our goal is to make this 5 and -3 0. But if we get 1 there, then calculation will be easier. So that's what I'm going to do. If I do that, so the R1 will remain the same. In R2, I'm dividing by 2. That's going to give me 0, 1, 2, -3, -3. In R3, I'm dividing by 5, means I'll get 0, 1, 2, -3, -3. And the last one will remain the same. Any questions so far?
No, sir.
Okay, now remember our pivot is this. So anything below that, we need to make 0. So we need to make this guy 0 and this guy 0. So how can we do that? Well, in R3, we'll do R3 minus R1. And in R4, we're going to do R4 plus 3R, not R1, sorry, R2.
R2.
Because this is the pivot, this is the leading entry. Okay, this is the pivot, this is the leader. So we always use the leader in order to make other guys 0. So this will be R4 plus 3R2. And what do we get? Let us write. R1, we did nothing. I just copy that as it is. And in R2, we did nothing. I just copy as it is. And now R3 minus R2. R3 minus R2 will be 0. R3 minus R2 will be 0. That will be 0. Oh, this is all 0. Right? This is 0. This is 0. This is, yeah. Okay.
Yes.
Good. Now, next, R4 plus 3R2. What do you get? 0, 0, 0,
0.
minus 5, 0. Is that right?
Yes, sir.
Is it in echelon form?
I think no,
Why?
because the leading entries are no, are also 0.
Yeah, exactly. So if there is a row that has all of the elements is 0, that must be at the bottom. So what you need to do is this R3 and R4, you may want to switch. Okay, I'm going to go from here all the way to there. Let me erase this. Here all the way there. So we're going to do R3 and R4. Switch. If I do that, I'm going to get 1, 1, 4, 5, -9, -7, 0, 1, 2, -3, -3, and then 0, 0, 0, -5, 0, and 0, 0, 0, 0, 0. All right. This is in echelon form, okay? This matrix is in echelon form.
Professor,
Yes.
whenever this situation occurs, as here the whole row was 0,
Yeah.
then this is not the equivalent form.
Well, this is in echelon form. The only thing is, remember the 3 properties? One of the properties for echelon form is that if there is all the 0 in the row, that must be at the bottom. Okay, if any row has non-zero number, for example, in here, there is non-zero number 5. And this row has all the 0. Therefore, it must be, the row with all the 0 must be at the bottom.
Okay, sir.
Yeah. Okay, this matrix is in echelon form now. All right. Sorry, guys, I just I pressed somewhere else. Anyway, now the question is, let us look at the question, what we are supposed to do. Identify the pivot column, basic variable, and free variable. Okay. identify the pivot. So pivot is this, and this one. I think it makes sense to everyone, right? In part A, pivots are 1, 1, and -5. Or you can write, you can divide that -5 by 5, and you can write 1 as well. Okay, so I'll write -5 here. So pivot may be different. It depends whether you want to divide or not. All right, next, pivot column. What are the pivot column? Column number 1, column 2,
and 4.
and column 4. Pivot rows.
1, 2, 3.
1, 2, 3.
Row 2 and row 3. Even though the questions ask us to find the pivot column only, then there is no harm writing, writing this pivot rows and pivots, okay? So that's it. Now, what are the basic variable and free variable? Very important words, guys. We'll be using this word over and over again throughout the course. Until the end of this course, we'll be using this, okay? What that means? What it means is, basic variable means, let me just write it down. Basic variable means it's a variable for the pivot column. Okay, and free variable means, the meaning is a variable for non-pivot column. Okay, that is the definition. Now let me ask you, if I write this matrix in system of equation, let's say this is our augmented matrix, okay? Consider this as augmented matrix, for example. Then this is your x1, this is your x2, x3, x4, and this is constant. We know that, right? We know that from the previous class. Now tell me, what are the basic variables here? Basic variables are, here is the definition. So look at the definition and tell me what are the basic variables, x1, x2, x3, x4, which are basic and which are free.
X1, X2, and X4.
X1, x2, and x4 are basic. Yes. Because these are the variable for the pivot column, right? And now what are the free variable?
X3 and X3 only.
Yes, free variable is x3 only. Any questions so far?
Professor, can you again go to that 3 properties of the which you shown earlier?
Okay, you want me to go to 3 properties of, okay. Here.
Thank you. I got it. Thank you.
Okay, all right. Let's go
Yes.
to part B. What is the questions in part B? Write the reduced system of equation. Okay, we want to write this matrix in a system of equation. How do I write that? So maybe part B, I'll go here, okay, part B. We need to write reduce system of equation. So reduce system of equation. So it means we have the augmented matrix, write this in system of equations. So we know that 1x1 plus 4x2 plus 5x3 minus 9x4 equals -7. All right, that's the first row. So we got, from the first row, we got first equation. Now the second one, 0x1, I don't have to write that. So 1x2 plus 2x3 minus 3x4 equals -3. That is my second equation. And the third one is -5x4 equals 0. Or you can write x4 equals 0. Or I can write this here, x4 equals 0. This is called reduced system of equation. Any question?
No.
Now let's go to the part C. We need to write, find the general solution of the system. Okay, we need to write that, we need to find the general solution for this. Part C. So in general solution, you always express, this is the form, this is the term where we will express the basic variable in terms of free variable. Okay, so here it means solve basic variable in terms of free variable. That's what it means. Okay. Now you see x4 equal to 0. Let me do the, let me just copy that system of equation from part B, which is x1 plus 4x2 plus 5x3 minus 9x4 equals -7, x2 plus 2x3 minus 3x4 equals -3, and x4 equal to 0. So I just copy as it is. Now my goal is to express the basic variable in terms of free variable. First of all, I should know what are my basic variable. I notice that the basic variable is x1, x2, x4. Okay, x1, x2, and x4. And the free variable is x3. In this case, if I substitute x4 equal to 0, so what do I get? x2 plus 2x3
Is equal to -3.
equals -3. And from this one, if I substitute the value x4 equal to 0, what I get here is that x1 equals -4x2 plus 5x3 -7. Is that right? I mean, not plus, this is minus. Okay. Now remember, x3 is free, so this must be, you must write this in terms of x2 only, because on the left hand side we need to have basic variable. No free variable is allowed on the left hand side. That's what I call solve basic variable, solve for basic variable in terms of free variable. So since x3 is free, so you may want to express x2 in terms of x3, which means x2 means minus 2x3 minus 3. Okay, we got x2 there. Now you substitute this value of x2 here and then get x1 in terms of x3 only, x3 and numbers. So this gives me, substitute the value. This gives me minus 4x2. x2 means minus 2x3 minus 3 minus 5x3 minus 7. So that's going to give me 8x3 plus 12 minus 5x3 minus 7, which gives me 3x3 plus 5. Is that right? Any question? Is my calculation correct?
Yes, sir.
Okay.
Yes, I got the same one.
All right. So then let us write it down. So the general solution is your x1 equals 3x3 plus 5. Your x2 equals negative 2x3 minus 3. And your x3 is free. And x4 equals 0. So this is called the general solution. One important thing is that when you want to write, when you want to express the given system in its general solution, always make sure that always solve for basic variable in terms of free variable. So the basic variable you cannot have on the left hand side. That's what we mean solve for basic variable. Okay.
So when we say that x3 is free, does it mean that it can be any number?
X3 free. We will talk about the meaning of this later, but what it means, okay, I just want to give you a heads up. X3 free means in this system there are 4 variables and 3 equations, right? It's over determinant system. That is what we call. So in that case, we always have some free variable. What it means is for X3, you can choose any value that you like, and still the system will be satisfied. Okay, X3 free means you are free to choose any value for X3. Okay, now let's try one question similar to this, and that's all about section 1.2. So I want you to try one example. Example 3. Oh, hold a second. Example 3 is pretty straightforward. Let's try example 4, and then we take a break. Consider the system of equation. Find the echelon form of the augmented matrix. Identify the pivot column, basic variable, free variable. Write the reduced system of equation and find the general solution of the system and blah, blah, blah. So let's work on that. Example 4. I'm going to do this here. Anyway, I'm going to do this here, okay? So example 4, solution. First of all, write the augmented matrix. Consider the augmented matrix, which is, you see this one is x1 will be 0, x2, x3, x4, x5, and constant terms. So in the first row, you will have 0, x1 is 0, x2 is 3, negative 6, 6, 4, and negative 5. In the second, we'll have 3, negative 7, 8, negative 5, 8, 9, and 3, negative 9, 12, negative 9, 6, and 15. All right. Please change it into echelon form. Okay, in order to change the echelon form, then the first thing you may want to do is interchange R1 and R3. And that's what we got. In order to make life easy, you can divide this R1 by 3 so that you get 1, -3, 4, -3, 2, 5, and then R2 and R3, I just copied as it is. Now your job is to make this guy 0 here, and this will be your pivot, and make that guy 0, and so on. And let me know what is the echelon form, okay? I'll leave it to you guys, okay? And so the echelon form, I think what you're gonna do is, what you're gonna get is the first item remains this, for first row will remain the same. This must be 0, 0. Guys, this is what I got.
Sir, I have a question. I know you
And I trust that you are able to get this echelon form. And now let us answer those questions given in that example. Okay, part A, find the echelon form of the augmented matrix. Yes, we did it. So part A, we did it, echelon form. This is in echelon form. It is not in RREF form though. It is in, oh, yeah, it is actually in, well, it is in echelon form, not RREF form. In order for this to change into RREF form, then anything on that column other than the pivot must be 0. So we need to make that 0. So we'll talk about that later anyway. So this is in echelon form. And our question is part B. Part A is done. Part B, identify the pivot column, basic variable, and free variable. Okay, part B, pivot column. What are the pivot column?
1, 2.
1, column 2, and this is also pivot. What is that column? 1, 2, 3, 4, 5. Column 5, right? So these are the pivot columns. Okay. Next, what is the next question? And what are the basic variable and free? Okay. So basic variables are, this is your, remember, this is x1, x2, x3, x4, and x5. So how we define basic variable? The variables in the pivot column. So what are the basic variable then?
X1,
X1, X2, and X5.
Excellent. And so what are the free variable means? Free variables are the remaining, right? Which is x3.
X4.
Yeah, that's it. Part B is done. Part C. Write the reduced form. Reduced system. So
I have a question.
Yes.
For the pivot column, how can the column 5 be like a leading entry? Like,
See, there is this one here. There is
yeah.
an If there is 0, then there will be only 2 pivot. But since there is 1,
Okay.
all right. So reduced system will be x1 minus 3x2 plus 4x3 minus 3x4 plus 2x5 equals 5. Next row will be x2 minus 2x3 plus 2x4 plus x5 equals 0. Next one is x5 equals 4. Okay. Is there anything that I did wrong?
No, sir.
Um,
No,
no, it should be
minus
-3 in
3, not
the second one.
Yes, that's what I'm saying. Remember, sometimes I intentionally copy the wrong thing, okay? You need to be very careful, pay attention. Okay, that is -3. So that is reduced system. And now what is the last question that we are supposed to do?
General solution.
General solution, okay. Part D. General solution. That means you must express basic variable in terms of free variable, okay? Solve for basic variable. This means solve for basic variables. So basic variable can be on the left hand side, but no free variable on the left hand side, okay? Maybe you can write this as, x3 and x4 free here as well. All right, guys, please solve it and let me know. Okay, so what do you get here? x1 is 2x3 plus, you got plus 9x4 minus 3. x2 is 2x3 minus. Okay, so after a little bit of a high school algebra, simplifying this, what we got here is that our x2 is 2x3 minus 2x4 minus 7, and x1 is 2x3 minus 3x4 minus 24. Therefore, so our general solution is, let us write this in a nice form. General solution is going to be, your x1 is 2x3 minus 3x4 minus 24. Your x2 is going to be 2x3 minus 2x4 minus 7. Your x3 is going to be, x3 is free, and x4 is also free, and x5 is 4. That's it.
Professor,
Yes.
the leading entries must be 1 always.
No. Leading entries is non-zero number.
Okay, sir.
And part E, what is in part E? I think there is another question as well. Let me just go there. Determine whether the system is consistent or not. If it is consistent, determine whether it has one or infinitely many solutions. Now, what is your thought? Is the system consistent? I think we discussed that issue in our last class. How we can say whether the system is consistent or not just by looking at the echelon form, right?
Inconsistent.
It is inconsistent?
It's my thought. I don't know I'm correct or not.
Remember, what we discussed in our last class is that if there is something 0 here and then on this side 4, then 0 equals 4 is impossible, because 0x5 equals 4 is impossible, but x5 equals 4, that is possible. So unless you get 0 here on the last and non-zero number there, the system is consistent. I think we discussed that in our last class. So since no equation is in the form 0 equals c, the system is consistent. Now the question is, if it is consistent, it has either one solution or many solutions. What do you think?
Any solution?
Why?
Because it can be anything. Like the constant.
Because this, what is the meaning of free variable?
Is the infinite.
Infinitely many possibilities. Okay, suppose you choose x3 equals 0, x4 equals 1. So x1 and x2 may have a different value. If you choose x3 equals minus 10, x4 equals to 10, for example, or 20, you get another possibility. So there are, when there is a free variable, what it means is there are infinitely many solutions. Okay, since there is a free variable, the system has infinitely many solutions.
Professor,
Yes.
is this possible to have one free variable and even then there will be just a one solution?
No, when there is a free variable, there will always be infinitely many solutions, because remember the definition of free variable. Free variable means you can choose any value for that.
Okay, thank you.
Yeah. Okay, so in order, in this example, we need to find the value of h that will make this given system consistent, and similar to what we did in our last class. So you consider the augmented matrix, which gives me 3, -9, and 4, -2, 6, and h. And then you change it into echelon form. And I trust that you know how to change it into echelon form. And so if you change it into echelon form, what you're gonna get would be okay. I'll wait for you guys. So take a few minutes and try to change it into echelon form. This is what I got, changing into echelon form.
Same here.
Okay, good. So remember, the idea is that if the system, in order for this system to be consistent, if this one is 0, then this must be 0, right? Otherwise,
Otherwise, it is inconsistent.
yeah, for the system to be consistent, this 0 must be equal to this one. So which gives me h equals -8/3. That's it. Okay, I think we pretty much did all of the concept that we are supposed to do in 1.2, but I think you may want to try one rref form. This is what we call reduce row reduce echelon form. Okay, so what is that? How do we get, how do we change the given given matrix into rref form? Let's try one example. Okay, I just want to consider one random matrix here. So maybe let me just copy and paste the matrix that we were working earlier, which is at the beginning of the class, maybe. Okay, so the first matrix that we were working at the beginning of the class was this. Let's say 1, 4, 5, minus 9, and minus 7, 0, 2, 4, negative 6, and 0, 0, 0, negative 5, and 0. And next one is 0, 0, 0, 0, 0. Let's say this is the given matrix. I want you to change to RREF. Change to RREF form. That is the question. Now, in order for this to change into RREF form, first always change into echelon form. Okay. So to change into RREF, first change the matrix into echelon form. But the good news is that this matrix is already changed into echelon form, right? It is already in echelon form. So that means it satisfied those three conditions. Now what we need to do in order to change into RREF form is that, you see, this one is your pivot, this is your pivot, and this is your pivot. So on the pivot column, all the members in that column must be 0 except the pivot. And the pivot must be 1. So two things. All the pivot must be 1. And that's the only non-zero number in that column. Then we call that system, we call that matrix RREF form. So first of all, we need to change all the pivot into 1. So the first pivot is 1 already, good news. For the second pivot, we need to change it, we need to make it 1. And for the third pivot also, we need to make it 1. So what you may want to try is that R2 divided by 2 and R3 divided by -5. So we have the pivot, all the leading entry is 1. So let's do this. So that you'll have 1, 4, 5, -9, -7, 0, 1, 2, -3, -3, and 0, 0, 0, 5, 0, 0, 0, 0, 0, 0.
It should be 1 instead of 5.
Yeah, we must. Oh, yes, I was checking how many
one.
clarifications. Thank you. It must be 1. We divided everything R3 by -5. Yes. So the first criteria, the property for RREF form, extra property, is that all the pivot is 1. So we made it. Another property is that except the pivot, everything must be 0 in that column. So that means we need to make this guy 0. We need to make 4 0. And we need to make this -3 and -9 0. That's all we need to do. Since the column 3 has no pivot, so we don't worry about it, okay? Just leave it as it is. So in order to make this 4 0 and -3 and -9 0, I suggest that, earlier, in order to change it into echelon form, we go in that direction. It's called, forward direction. We try to make this guy 0, this 0, this 0, and then only we look at the second column and then the third column, and we try to make those zeros. But once you change it into echelon form, okay, this is, now you have to do the backward method. So that means first you may want to try to make this -3 0. Okay, first try to make -3 and -9 0. How to write that? First try to make equal 0 by a row operation, and then only, and then make 4 0. Okay, this is my hint. Okay, first forward method and now backward method. So always go from this direction. So we look at the last column always in this case. That makes calculation a lot easier. So my goal is to make this -3 0, -9 0. So what I need to do is in R2, I do R2 plus 3R3, because this is the leader and we must use that leading entry to make the 0 in that column. So that way I can make that -3 0. In order to make this -9 0, what I need to do is in R1, I'll do R1 plus a 9R3. That way I'll have both 0. So in R1, I did nothing. I just copy as it is, 1, 4, 5, -9, -7. And in R2, I did R2 plus 3R3. Let me do this in this rough work here. R2 and 3R3. What do I get? R2 is 0, 1, 2, -3, -3. And 3R3 will be 0, 0, 0, 3, and 0. So if you add them, you're going to get 0, 1, 2, 0, -3. Okay, let me write that. 0, 1, 2, 0, -3. And in R1, we did something. So hold a second. R1, I'm going to erase that part. In R1, what we did is in R1 and 9R3. So let us do the operation. R1 is 1, 4, 5, -9, -7, 9R3, which will be 0, 0, 0, 9, 0. So if you add them, you're going to get 1, 4, 5, 0, -7. So this will be 1, 4, 5, 0, -7. And R3, we did nothing in R3. Let me just copy as it is. And R4, we did nothing, just copy as it is. Okay. Now your job is to make this guy 0, this 4, 0. In order for this, remember, this is your pivot. So use that pivot in order to make that 4, 0. So what you may want to try to do is in R1 minus 4R2. Okay, let's do it. What we decided to do is R1, let me just copy R1 as it is, which is 1, 4, 5, 0, -7, and -4R2. So that's going to give me 0, -4, -8, 0, and 12. If I multiply this R2 by -4, that's what I'm going to get. Now, if you do the calculation, you're going to get 1. This will be 0. This is -3, 0, and 5. Let me just copy this value here. So I get 1, 0, -3, 0, 5. And then R2, we did nothing. Let me just copy as it is. 2, 0, and -3. And then this will be 0, 0, 0, 1, 0, and 0, 0, 0, 0, 0. Okay, now it satisfies that extra two properties as well. So what are those extra two properties? Is that all of the pivot must be 1. Yes, all these are the 3 pivots and all of them are 1. And in each of the pivot column, okay, in each pivot column, that one pivot is the only non-zero number. Every other element on that column must be 0. And we notice that this is your pivot column and this is your pivot. Except that pivot, everything is 0. This is your second pivot column and this is your pivot, and except the pivot, everything is 0. And since this is not a pivot column, we are not interested on that. Whatever there, we don't care. And the third pivot column is this, and this is 1, and everything else is 0. So this matrix is now in reduced row echelon form. In short, we write rref.
Professor?
Yes.
Sir, is there any diagonal relationship compulsory between the pivots?